Alright, so our real last order of business here is to talk about t-distributions. And like I said before, I don't want you to do too much with them this week. What I want you to know is that you use the t-distribution if you're doing a small sample confidence interval. And again, the t-distributions come from a family of distributions that have different shapes for different sample sizes. For a large sample, where n is greater than 30, it's shaped like a normal distribution. For small samples, you get different shapes, but in general the trend, and this is very exaggerated, you have different shapes. They tend to have fatter tails and a shorter peak. So that means you have a greater probability of getting sample means that are out here or out here, and a lower probability of getting sample means that are close to your overall mean here. If you're calculating a confidence interval for a small sample, you would use the following formula. Where everything is the same as in the last couple of examples, except that you're using a critical t statistic instead of a critical z-value. So what this means is that, whereas before we were looking at the z-scores that were on either side of our point estimate, now we'd be looking at t-scores or t-statistics that are on either side of our point estimate. And again, I'm not going to have you actually calculate anything with these t-distributions for now. I just want you to know that if you're working with a small sample, this is the equation that you would use, and this is what a t-distribution looks like. One other thing to note about t-distributions is that we will always talk about estimated standard error rather than standard error when we're looking at t-distributions. So we'll be we'll always skip right to this estimated standard error part if we're talking about t-distributions. And typically t-distributions are used when you're using a sample to try to figure out what the what the sampling distribution is for a population. So we're estimating our standard error, and we're leaving some extra wiggle room in the sides if we have a small sample, and we can be less sure of what our results are because of the smaller sample. And again, not going to be too much of anything you need to know about these next week, aside from the fact that they're sampling distributions, much like the normal distribution. They have t-scores or t-statistics instead of z-scores. And you can do similar things with them, like calculate confidence intervals for small samples. And they better account for the things that happen when you have a small sample. So that's it on t-distributions for this week, and now I'm going to pop back to the slides for one more quick look at confidence intervals in a real-world application.